Hello, everyone. Welcome back. This is episode 3 in the Azure Defender for IoT series. We have Richard Diver here with me again. We also have a new guest here, James Cabe. James, want to introduce yourself?
Yes, my name is James Cabe. I'm one of the Defender for IoT global black belts. I came over with the CyberX acquisition and glad to be here.
That's awesome. Thanks so much, James, for joining us. So Richard, in episode 3 here, what are we going to be doing today?
All right, so today we are actually going to build this offline sensor. So we've taken all the files, we've got the install file, and we've got the licensing file. So now we're going to go into Hyper-V and we're going to actually build something.
All right, well, let's jump into it. Okay, so I'm guessing we're just going to create a standard virtual machine here like normal?
Yeah, let's go ahead and give it a sensible name so we can find it again in case you have lots of them. And for this one, we can build it fairly small, but hopefully you've got at least somewhere between 6 and 8 gigabytes. Should be enough to get us going in an offline sensor.
Okay.
Now,
Generation
generation 1, please. A new and very interesting thing that just came up as one of the, and I'm going to make quotey fingers here, features of the sensors now. It won't matter as much when you give the name in Hyper-V, but if you do end up giving it a host name now, and you change that in the GUI, and it's different from what you get in Defender for IoT sites and sensors, if those two don't match, it no longer authenticates properly to the Defender for IoT portal. So it's an added secret. It's another form of multi-factor authentication with your Defender for IoT hub. So just to understand that right now in Hyper-V, it won't matter about the name, but names do matter just like they always do in Unix, which capitalized stuff also will matter as well. So sorry about that. So
No, it makes sense. Yeah, that's a great point. So in terms of RAM, what should we be looking at just as a test here, as a dev test environment? Gig of RAM, 8 gigs of RAM?
I always start with at least 2 as a startup memory. Yeah, and then it'll balloon up to whatever you allow it to have, unless you want to use fixed, and then you should do somewhere between 4, 6, or 8, whatever you can afford.
All right. So we do have 2 NICs on here.
Yeah,
so
good. I was going to say, one of the things you will need is 2 NICs, because the VM is expecting you're going to connect to 2 different networks.
All right. So we'll just add the first NIC first, and then we'll come back and add the others. And what's the minimum disk space that we'd be looking at? Or what should we assume here?
At least 50 gig.
Okay.
So I'd stick with the default that you have there, or 80, that's fine. Again, if you're doing this in a production environment, follow our guidelines online and make sure you have the right specifications for a production. But for when we're doing this in a virtual machine and we're just testing, we're really not going to use a lot of hard drive space or memory.
Okay. And I've got the sensor ISO here loaded in.
Excellent.
And we do need to add that second NIC, so let's go through and do that.
I also find it handy to increase the processes to 2 virtual processes. That's just in general. I don't know if that'll make any difference on this one, but it's a good practice to have.
Oh no, this is a very multi-threaded engine. Having two is minimum and 4 is best. So
okay, that's why I like having James on. He can always give.
That's right. All right, so.
Yeah, so this process now is going to take us through a nice guided steps of things that we need to input, and then it's going to run a whole lot of automation on its own as it builds, and we're going to see that happen. And we will pause the video and skip forward when it gets to those times. So for this one, we're going to go through and choose the option that says Office. It's the one in the middle there. Now it says 4 CPUs, 8 gig of RAM, 100 gig of storage. That's what you should be using in a production environment. But for this test environment, we've got a good build.
Okay.
All right, so this is us kicking off. This will take about 10 to 15 minutes.
Okay, it looks like we're finished with the initial process. So Richard, where do we go from here?
So now we'll type in Office again. That tells us which profile we're going to use.
Okay.
And then we should be prompted for our network configurations. So first of all, we'll configure ETH0. This will be our management NIC. So this IP address range we're going to put in here is the one that's going to allow us to get into the device from the management perspective, so we can actually see the web UI.
Okay. I'm just going to do a 10.address just to make this easy.
Yeah, if you're doing this at home, make sure you don't use an IP address range that's kind of already in use somewhere else, otherwise you might get some conflicts.
Yeah, like in my
interesting
case.
though, if you do want it to connect to the internet, it would need to be an IP address that is internet routable. So,
Right. But in this case, this is an offline sensor, so we would not. Okay.
And you can always use NATing as well. So Hyper-V allows us to hide that.
Now, does it need a DNS server in this case?
We're not connecting to the internet, so no.
Yeah, I'm just going to point back to itself then.
Get away with a lot in a test environment.
Right.
All right.
ETH1.
Yep.
So ETH0 would that be our management network, and ETH1 would be our
Exactly. Yeah. And we're not going to
network?
create a bridge, so we don't want to bridge these two together. So you can just press return here.
Okay.
And then yes. All right. Now this will take another 10 or 15 minutes, and then we'll get to the final steps.
All right. We'll pause here. We'll come back. Okay, we're back, and I took a screenshot of the password here, but can you quickly explain what is this that we're looking at?
All right, yeah, this is a really important step here. This is the point where we're giving a user ID and password to get into the console. So the first one we give you is called CyberX. So take a screenshot of that so we don't lose it.
All right, quickly save this.
And then when you press enter, we should get the next one, which is called support. And we'll take a screenshot of that one as well. Now, going forwards, you should really only use the support login. The CyberX one is if you call us for support and you need our help, we may get you to log in with the CyberX user ID instead. But the support one is good enough for everything you're going to need to do, including creating more accounts in future to use for things like read-only access or the lower level admin permissions.
So day-to-day ops uses support credential?
For configuration and management would be support, and then you'd probably create another account that you do for kind of day-to-day monitoring and tracking.
Got it.
Yeah.
Okay.
And that's the only time you get to see that user account and password. So if you didn't capture it right there, you're probably going to be rebuilding the machine.
Mm.
All right.
I usually use the support account myself to actually configure the Active Directory integration. So
yeah, that makes sense.
And then after that, I don't touch it. Really don't touch the support account again.
So now you have to click on Advanced in this window. And then
or you could just type in a blank spot, this is unsafe, and it works too. Special ninja secret.
Excellent.
Love it. So we're going to use the support username, I'm guessing?
Correct.
Okay.
Right, and now this will be the first point where we have to activate the device as well. So now another point to note here is we had two different options. We can download a file for an online sensor and an offline sensor. The only thing that matters here at this point is we want the offline sensor because we haven't configured it for internet access. So if you want to use an online sensor, it will need internet access at this point, otherwise it won't activate. So for now,
interesting thing to do is go take a look at those zip files real quick, just to kind of go over that real fast and show you what's actually in them to show you how that works. So if you take a look at this, you get a JSON file, and the offline one, you will notice it doesn't actually nail it up to the IoT hub, and the online one will give you kind of a little bitty scriptlet that attaches it directly to the IoT hub. And then both of them, you'll notice, have PEM keys or certificates built into the thing. One unlocks the license, and the other actually gives it a multi-factor authentication piece. So if you did later connect to it via the IoT hub or some other API service, it's got a certificate automatically provisioned for it to kind of lock it down. So that's to get around the issue that usually happens when you deploy some hardware appliances. They've got these self-signed certificates and they're super duper insecure, and you can have supply chain issues with them. And that that fixes the problem once you get this thing licensed.
That's super interesting. Wow. Okay, that makes sense. So we're going to use the offline activation file, I'm assuming here. Now, do I need to unzip it, or can I just upload the zip?
How? Upload the zip.
Okay. Activate.
Okay, so this is if you have a certificate authority that you already use inside the company itself, and say you have a CA for yourself, or if you're going to deploy this thing remotely and don't want that certificate error when you first come to the console, you can actually import the certificate immediately. And so there is a certificate service built into Azure where you can export a certificate very quickly for a server certificate directly into the appliance and really make the web interface a little bit even more secure than it already is. So, but in this case, we're probably just going to do, because we're using this for testing only, just generate the self-signed certificate and be done from there. Yes. Finish. Excellent. And there we are. Richard.
Wow.
Excellent. Yeah, so the first thing that I like to do here is just have a good look over and see what we've got access to. We'll go through all of the navigation on the left-hand side. But to start with, if you scroll down in that menu on the left, you'll see that there's a system settings. So this is the first place to come to make sure. As we're looking here on the right-hand side, you're going to see the threat intelligence file, and there's an update date of the April 19th. So whatever day you're listening to this video and you're doing this on yourselves, you want to make sure that you've got the latest and greatest update files from Azure, and you import that and update it. Now, if it's a cloud-connected VM, it's going to automatically keep that up to date. But if you're running in a lab environment or an offline network, you're going to have to import this manually.
And while this is importing, maybe just a little bit of information. What exactly is contained in that threat intelligence file? Are those hashes or for file names and IP addresses and typical threat intel, or is there anything specific to Defender for IoT? What does that threat intelligence look like?
That's a really good question. It's a collection of indicators of compromise that we collect over the months in between. We usually put a file out once a month. If you install the on-premises manager, you can actually do updates to multiple sensors en masse from the single file, right? So you can automate that threat intelligence update. You can also, if you had this thing cloud connected, if it was cloud connected and you went to your Azure portal, you can actually update the intelligence file directly from the Azure portal itself, or set up an automated schedule to do so. What that file is we indicate at the Azure Defender for IoT, it indicates on not these ideas behind IPS signatures, which are kind of static signatures for deep packet inspection. Mm-hmm. So if you think of Suricata or some other open source IPS unit, it's not that. We indicate on TTPs, if you think of the MITRE ATT&CK framework. So if you've ever talked or heard about the MITRE ATT&CK before, it's really trying to canonize a set of steps that a kill chain takes. So lots of people used to know it as a cyber kill chain, and this time it's the attack framework is sort of the updated version of that. And so we indicate it on TTPs as opposed to signature basis. So that allows us to do behavior. It allows us to indicate at different steps where something may be trying to intrude and it's a 0-day attack. And instead of indicating on something that you might not be able to detect, like a malware file or an IPS attack, we indicate on, wait, that looks like lateral movement. This looks like a command and control architecture. It looks like someone's trying to upload new firmware to the PLC and it's unauthenticated. Those sorts of things are what we do, and that's part of a set of TTPs as opposed to signatures that you have to update. Because normally, if you deal with an IPS unit or a next generation firewall, you're having to deal with hundreds of megabytes of IPS signatures a month. Here, the last file I saw that was almost a quarter's worth of, so 3 months worth of TTPs was a little bit under 12 megs. So wow. Very small file, very easy to deploy.
Wow, super interesting. Okay, so we've updated the threat intelligence.
One other thing that you can do from this is if you scroll down in this menu, you're going to see this ability to do backups and restores, and also the level of protection. So these engines always need to be running, all 5 engines. And if they're not running, then we can go on and help and get them restarted. You see these are all enabled.
Okay.
There's also a sanity checker too. If you go to the very top of the system settings and you check the system statistics, which is that heartbeat looking icon at the top left hand corner, you can actually go to the appliance for the sanity check and check all the core daemons that run the thing itself to make sure that everything's healthy.
Now, that's actually a great question. I'm sure some that are watching this might be wondering, can I do SNMP traps from this and being able to monitor the health through, System Center or other means? What does that look like for these offline sensors?
So we do have a MIB for SNMP, and you'll see the SNMP configuration should be in the bottom, I believe, in this one. So integrations,
there it is.
SNMP MIB monitoring. So there you go. You set it all up there along with secret keys and encryption if you're doing V3. And V3 is basically stacked on top of V2, and V2 is stacked up on the top of V1. So you do all the authentication types, and if you have a certificate, this is where if you deployed a certificate automatically to the device at the very beginning of our talk here, where it gave you the option to import a certificate. A lot of this stuff can be done at that time for SNMP as well. So, but yeah, you definitely always want to deploy V3, and you can actually do that through here.
Nice, perfect. Okay. Well, this is so far pretty easy and straightforward. So we got the offline sensor set up here. Is there anything else that we need to do in our initial setup? Or are we ready?
I like turning on a few things.
Okay.
Just because I want to make it an offline sensor, and I want to be able to basically take PCAPs, not even directly connected to a network, and take PCAPs and dump it in here. So one of the next steps you're going to take is actually enabling the PCAP player directly in the GUI. And you can do that from the system settings. There's this system properties icon under general at the bottom right-hand corner. And you're going to click on it, get a warning that if you mess around too much in here, it's going to break it. So go ahead and click on OK. And then on the left-hand side, you'll scroll down till you see the word PCAPs. That's PCAPS. There you go. And you're going to scroll all the way to the bottom on that particular file. And you'll see it says enabled equals 0. That's just an exposure in the GUI. So just go to 1. And depending on the size of the sensor, and we provision this one pretty small. So I usually limit the amount of player size and stuff like that at this point to, I don't really mess with those 2 numbers at the top. I only do player parameters, and I do, where it has player params, and I do a minus sign. And then the capital M as in Mike. And then I do a space, and then I do 5. And what that does is that limits the number of megabits per second to 5 megabits. And for all you playing at home, that may seem like a low number to you. But most OT networks never run over 256K of bandwidth for the entire network. So that's actually pretty big if you're talking about OT telemetry networks. Now, the megabyte 5, make sure that you're not going to get laggy when you do run the PCAP, that the sensor will still maintain its GUI integrity and stuff like that. It's not going to ever kill it. It will simply buffer if it's running behind. But this is one of those things where when you limit it like this, it stays a lot more real time. Any questions, Matt, on that one?
No, that makes sense. That's a great little hack there, and that makes complete sense. So go ahead and save then, or anything else you want to adjust? Okay.
Nope. Perfect. Now, there are a few other things too that you can do a little bit later on if you're actually actively deploying this. There's a few other things to enable if you really want to expose a few things. And one of them is the Horizon interface, which if you go to the top right there, you can actually do the UI enabled equals true. And then go ahead and save that again. And then last but not least, underneath the global title, which is a little two sections up above, there you go.
and you're going to go scroll down and look for auto discovery, and it's going to be closer to the bottom. So scroll up a little bit more. Sorry about that.
Here it is.
Excellent. Just go ahead and make that equal 1. Now, what that does is that most people, so one of the things to understand about Defender for IoT is that it is a passive sensor. The whole point of it is that it doesn't ever put any pressure on the network by actively going out and polling these assets, because you can knock over lots of OT equipment just by pinging them sometimes at the wrong size packet, right? Or opening too many sessions on it over a period of time, and it'll just stop responding. And somebody has to go out and climb a tower in negative 30 or 40 degree weather, which is very dangerous, and then actually physically reboot something. And you don't really want to endanger someone's life because you were actually, polling a piece of equipment you probably shouldn't have been. So this auto discovery is that active polling, but the sensor is 100% passive unless you enable these features. One good thing about enabling the auto discovery features is that if you find something on the other side of a firewall that you have to really reach out and touch, that is one of the easiest ways to do it, is to actually do the auto discovery and set up those networks to go out and poll them if they're not brittle. So this is perfect. Go ahead and click on, if you hadn't clicked on OK already or save, now you can go ahead and click cancel and everything's good to go. You should, if you scroll down to the bottom of system settings now, you should see the PCAP player automatically.
Oh, there it is.
Excellent.
Okay. Perfect.
Yeah. So Matt, I've sent you some PCAPs that you can have a play with. If you want to go and look in the chat window and get the files and pull that down, we can get those uploaded.
Yeah, let's do that. Let me download those now. And
for our audience, you can get PCAP files on the internet. We'll put a link in the description for where you can go and get some of your own PCAP files, or take them off your own networks as well, using something like Wireshark.
Now, one of the things that you'll notice about some of these PCAP files, especially when it comes to OT PCAP files, they'll be like 1K or 640 bits. So they'll be extremely small. Some of that's actually over 24 hours worth of capture. These networks are extremely low bandwidth, but they're real-time protocols, which basically means that the stuff doesn't require an application to talk. It's two machines talking to each other. So when they do talk to each other, it's a lot more, it's not two applications talking to each other like we're used to with TCP/IP. It's more like your video card talking to your CPU, right? They actually talk in machine code directly across these OT networks. So that is definitely something to note, that they're very, very small files. So if you're freaked out by the small PCAP files, don't be alarmed.
So all you need to do that is in the PCAP player there, click on upload and browse, and you can select all those files in one go.
Okay.
So select them all. Up to 20. We can change that in the settings, but for now, it'll just upload the top 20, but you can make that more if you want. So now when you click on play all, it's actually going to ingest each one at a time and do the analysis. And so over on the left-hand side, if we go back up, you're going to see the alerts are starting to appear. So if you click in there, you're going to see alerts. This is as if it was live. So as we're playing the PCAP files, it's like it's listening to the network and ingesting the data and seeing things in real time. Obviously, you wouldn't want this much happening in one go in your network, but sometimes that happens. If you go into dashboard, you'll actually see this all starting to appear in dashboard. And it's still processing in the background, so it's going to change. But now you get to see what this really looks like. So we've got alerts, we've got the timeline, you can see the kind of violations that are coming up, seeing where the problems are being discovered. The other nice thing to do, and we'll go into device map, and you can see a really interesting view here that as we, click on that one. So now if you zoom out a little bit, this might take a bit of time to build because we've got to wait for it to finish processing. But what we're going to see is actually communications between devices, and then we're starting to build a map out. So once all those 20 are ingested, we'll come back to this and we'll see a lot more data in here. If you look at the device inventory, you're going to start to see the devices being populated. And these are the
pop up
addresses, protocols.
Device.
Oh yeah, the device map is now ready because we've got 57 devices in there.
Wow, look at that.
Yeah, now it doesn't look like a lot here, but when you zoom in, you're going to start to see the connections being built out. So if we zoom back out again, We can change this layer approach. If you click on the little hamburger menu and the blue bar at the top, you can change this to a different type of menu. So if you scroll down, well, one thing it's showing us actually here is it's showing us all the different protocols it's found, all the different subnets, applications, and other cross-subnet communications as well. The one I wanted you to actually click on, which I didn't tell you to, is the layered one. It looks like two squares, one layered on top of the other one. That one's going to allow us to lay out by Purdue model. Now, in one of the previous videos, you'll have seen us talk about the Purdue model. You can also close that hamburger menu again. So now what this has done is moved the location in the diagram of the devices and has put them into enterprise at the top, so where we'd expect it to be potentially risky activity like internet connectivity. Then we're down into the supervisory level, so we can see that the internet is connected down to one of these devices, and then it has come down into the supervisory level. And so these all have internet access. So we want to investigate these and understand, is that a risk or not?
Now, what do those levels mean again, Richard? If you can, talk about, what each one of those individual levels will mean for a set of users, because I know we don't always have a bunch of OT cyber people, listening to these videos.
Yeah, absolutely. So the enterprise really is that IT side. What we see today, every day in the office or in the major networks that have internet connectivity is the enterprise side. But once we step into that supervisory layer, the supervisory layer is one below like a DMZ. So I think the best way to imagine it is if you put the enterprise layer is the very risky area, say the internet, the supervisory layer is a place where we don't want anybody getting into there that isn't authorized. So to get into supervisory, really should be going through things like secure network connections, multi-factor authentication, secure devices. Now in the supervisory layer, what we have is a whole bunch of normal type of network and IT devices, but specifically used in the OT world. So we're still running Windows, maybe some Linux in there. And these are the devices that might be used by operators' consoles, configurations and laptops, and things that are making alerting and monitoring and reporting. The next layer down, though, this is where the process controls actually happen. So if we go further down, there's a new layer. You can see this gray line coming up. Now, further down here, these are all PLCs and controllers. This is all our process control. Anything getting into this level is actually making potentially physical activities happen on things like fire safety suppressors or mechanical arms that make operations move, conveyor belts, etc. So the further down this list we go, the more dangerous and risky this activity is. And
there's even further down the rabbit hole. If you click the available updates little icon in the top left-hand corner of your screen, it'll update the map again. And if we go back down to the process control level again and zoom back into some of those devices in the middle, you will see on some of those, they have a little bitty icon on top of them to the bottom little right of some of those devices. It looks like a little circle. And those actually are representative of them having a backplane. And backplanes are very odd pieces of equipment. So if you right click it and go to view properties, you'll get to even go down further down the rabbit hole, right? And you'll see that those backplanes have some of them have a number on them, and that's a network within a network. And sometimes you can see these things cascade 50 to 100 times, depending on how complex the process they are running. So if you go into like a bottling manufacturer that's pouring syrup and has like these bottle cappers and they make bottles and blow the glass and cool them and then fill the soda up and then do all this other kind of stuff, you're going to see PLC controllers 20 layers deep with hundreds of PLC controllers, programmable logic controllers on those chains. If you go to that little bitty, I think it's number 1 on the third on the backplane. That's the one there, the one that's on 3. Click on that, and you'll go to a deeper network even, and you can see there's another PLC even plugged into that via the backplane. So these are cascaded larger networks even in on themselves. Wow. And you'll get all this data that deep into the network. So this is kind of beyond deep packet inspection. This is even content and encapsulation detection, which is something that your typical IPS unit just isn't capable of doing, especially for asset management.
Yeah, and it's amazing, I think, that we can capture all this information and do this kind of investigation purely by looking at the broadcast traffic. We don't have to do any active scanning. We're not sending packets out across the network, which could potentially cause more issues, we're able to do this in a passive read-only kind of mode.
That's a really good point. Yeah, non-intrusive.
Yeah.
Now, this is just amazing, and I'm sure some folks might be wondering, can I export this view? Like my Visio friends might be wondering, can I put this into Visio and clean it up? Is there any way to export this?
Over in the top right-hand corner there's some icons you can use. And you can export them to Excel. Now, you can't export them as an image today, but what's coming is we're making a lot of progress in Azure itself. So when it's connected to the internet, you're going to see a lot more functionality available on the internet side of this. And that's one of the reasons why we want to have more internet-connected devices instead of having them all in an offline network. So updates are coming in the future to make that more available. But for right now, you could zoom in, you can manipulate these, you can move the devices around, and you could take screenshots. Is probably the best option for today.
Wow, this is just amazing. So I think we've talked about a lot for today. We've got the sensor set up. We loaded some data into it. We made some configuration changes here. I don't want to steal our thunder too much for future videos because I know we want to go much deeper into this because there's a lot more to talk about. But in regards to just staying up that offline sensor, is there anything else we might want to mention to folks before we wrap up?
That's everything. What have you got, James? Anything else you would add?
You know, not really. This before we actually close up with like the setup, the one thing I will have to say is if you go down to system settings at the very bottom, one of the things that you want to do before you say this thing's a golden image and ready to roll is if you go to the top for the Active Directory authentication, I usually don't use the support login very often. I'll do it once to really set up my Active Directory integration. And set up a bunch of user accounts which have role-based access control. Basically, I can lock it down to people that can actually do administrative level in the box and then people that can't. And that's really the key piece right there is I usually set that up and then I don't ever use a support account again unless it's like a break the glass kind of situation.
Mm-hmm. That's a really valid point. Actually, I would even think about before deploying the sensor, if this was production, let's do a little bit of design planning here. Let's talk through how we can authenticate SNMP traps. I even see ServiceNow integration. So probably a little bit of design planning needs to go into this, but that's a great point. Well, guys, this is amazing. We got this stood up. So in the next video, Richard, what are we going to talk about? What are we going to go through?
Yeah, we're going to invite James to come back on the next video. And what we're going to do is go deeper into what we can actually do with this. So you've seen us very quickly go through the facts and have a look around at things like diagrams, and we can see these alerts. But what can we actually do with that to do some real investigations and risk detection and threat prevention?
All right, I can't wait. Well, James, thank you so much for being here and walking us through this and all of your wisdom and knowledge. Really appreciate it. And Richard, thank you for walking through it as well with us. This is a lot of fun. Hopefully everybody found some value in this, and we'll see everybody in the next video. Take care.